So today, let's etch some silicon. So if we're gonna etch silicon, we need to etch in hydrofluoric acid. That is something you don't do at home. And you have to wear the proper PPE. So we're gonna wear our goggles. We're gonna wear our well-worn and used lab coat. We're gonna have pants on, not shorts, even though it's hot outside. All right. Gonna have to wear gloves. We're gonna double glove, nitrile gloves, 2 layers of those. I'm not gonna wear my watch because if I did get something splashed up around here, 1, it would be bad for the watch glass. Remember, hydrofluoric acid dissolves glass. And 2, if I got some on my hands, I'll need to rinse my hands for 15 minutes under cold running water. So I don't want my watch on there, and I don't want to be trying to get it off if I did have a splash. So we're not gonna do that. If we had a spill, this wouldn't be enough. We would have to use heavy rubber gloves over top. But we're not going to have a spill today, so we're going to double glove. We're going to pay attention to the hydrofluoric acid. Make sure we don't spill it. Make sure we don't get it on ourselves. The reaction is highly exothermic, so we're going to have to do it in an ice water bath to control the temperature. Today we're going to do metal-assisted catalytic etching. MACE, also sometimes called metal-assisted chemical etching, but I prefer catalytic etching. So we're going to put some ice in here, make an ice water bath. We'll put some water in there. We're going to take some silicon, we'll measure that out on our top loading balance. Put it in a nice Teflon beaker. We're going to disperse it in some acetic acid, and then we'll add the hydrofluoric acid to that. Got to be careful with the static. You'll see it gets on the side. We'll bring that down off the sides with our acetic acid. We can use glassware with the acetic acid, which we've got here in a huge bottle. Now, acetic acid, why are we using it? It's going to be a surfactant, it has very low surface tension. But because it has very low surface tension, it's a pain to pour, especially out of the big bottle. So I'm not going to pour it out of the big bottle. Instead, I'm going to use a big pipette. The graduated cylinder filled up with our 30 mLs in this case of acetic acid. We're going to pour that around the sides a little bit to get the silicon off of the sides. Swish. It's going to stick in a clump in the bottom. Therefore, we need to disperse it. We're going to slip a stir bar in there. Put it in the ice water bath. And start stirring. Get it started around 90. Eventually we're going to stir about 150, 180 RPM. Right now it just gets started. We'll let it chill down a bit. Then we're going to add the HF. Don't let it chill all the way down to 0 degrees C. The acetic acid will freeze first. When using hydrofluoric acid, as I said, got to use plasticware or Teflon. We're going to use a pipette to transfer into the graduated cylinder. Now we've added the HF, we've got the stir bar in there, we've got the silicon in there, we've got the acetic acid in there. We're going to let it sit for 10 minutes to make sure it gets down to temperature before we start injecting copper sulfate. So we're going to load up a syringe with copper sulfate, 6 millimolar copper sulfate in water. We're going to load that syringe up. We're going to put it on our syringe pump, inject over 15 minutes. Then after the injection is done, it'll sit there for 5 minutes under stirring to let the copper form nanoparticles on the surface of the silicon particles, and that's what we're going to use to catalyze the etching. Okay. When you do that, you got to be careful not to include air bubbles. So we're going to pull some solution up in. There are going to be some air bubbles in there. You got to tap, get them to the top, make sure they're not stuck to the plunger head. And then make sure all the air is out. We don't want an embolism, as it were. We're going to load this then into our syringe pump. In the syringe pump, it's got to go up. The wings of the syringe go up against the bulkhead connector. Put that in place. And then don't forget to put the block against the stopper. We'll input the correct rate of injection and the volume that we want. And now we're going to start the injection, 15-minute injection. Simple as that. We wait 15 minutes. Okay. After the etch is completed, we need to filter the powder out of the etchant. So we're going to need, again, a nice plastic Buchner funnel, not a glass one. And we're going to use a filter paper sufficiently small. We want to know the mass beforehand so that we know how much product we actually have. So we're going to take the mass of our filter plus the top of the Buchner funnel. For the Buchner funnel, we need a vacuum seal down here. So we attach the top of the Buchner funnel to the base, pop that in our filter flask, and then we're going to hook that up. In this case, instead of a pump, we're going to use a water feed on this one. Because again, we may be dealing with some HF fumes, and eventually we're going to turn on water. That'll create our vacuum, cool the etchant off of the powder essentially. The powder will end up here. Don't forget to wet your filter paper and get it to seal nicely against the bottom of the Buchner funnel before you pour the etchant in. Okay, we're done with the etch. We've pulled out the syringe. Give it that 5 minutes at the end under stirring. That lets us get ready for filtration. So we got the top on there. We've got the filter paper in the center of our Buchner funnel. Make sure it's in the center. Then we need to seat it. So we're going to start pulling the water through. So pull the vacuum. And then start wetting the filter from the center and go out to the sides. Take a look, make sure there's no puckering. Don't want it to pucker, your etchant will get around it. Good. That's well seated. Now we're going to wait for the sample to finish. Got about a minute to go. Then we're going to take the stir bar out. We'll rinse that separately. Pour the solution in, and we're going to rinse with a combination of, first, we're going to be rinsing with some dilute HCl. Then we're going to add some ethanol that'll keep the foam down, gradually switching over from the dilute HCl to ethanol to get the etchant out of there, get all the etch products away. Our final rinse step will be with a pentane wet. And now, rinse it down with ethanol. Make sure you get everything off the sides. Okay. Of rinsing is we're going to let the pressure off. We'll pull the top off of this. Get rid of any. There's always a little bit of water left behind, ethanol there. Shouldn't be HF because we rinsed. Our final step to avoid and minimize capillary forces on our porous material is to do a pentane last step. We wet it all down with pentane. and then let that evaporate. It forces the ethanol out of the pores, forces any etchant that's left. There shouldn't be any etchant by now, but pentane will force the ethanol out of the pores, filling it with low surface tension liquid, which leads to much lower capillary forces during drying and better porous material in the end. Now we'll let that evaporate, then we'll stick it in the oven to vacuum dry 50 degrees C overnight.